In this brief video sequence set, we'll do some exponential modeling. So we'll talk about the setup and graphical thinking. So here, let's just review an idea with exponential modeling. So here, our growth factor is 2. Our initial value is 3. That means these outputs are growing by 100% for each input increase, a 1 unit input increase. So when t is 0, we get y is equal to 3. That's our initial value. That's no surprise. 2 to the 0 is 1. 3 times 1 is 3. And we could continue to do this, and we'd notice that the values just are double to what they were previously. So the y new divided by the y old is equal to 6 over 3, which is equal to 2. 12 over 6 is equal to 2. So there's our growth factor popping out at us. But in terms of rate of change, we notice that the rate of change is not constant. So the initial point that we plot is 0, 3. So I plot the point 0, 3, and then for a 1 unit increase, well, I jump from 0, 3 to 1, 6. So 4, 5, 6. So we're now up here. So this blue line represents the change, which is 3 units. But as I go over 1 more unit, my change in my output is now set up so that it jumps to 6. Well, 6 is just double the previous change. So in other words, if I were to label this with kind of this pinkish line, and I were to take that same length, the length of growth here represents half the length of growth here. And so as I start to put these together, I kind of notice that it starts to get a little bit of curvature and grows faster and faster. So that's one connection that's important to make, is that the amount of growth, well, when the growth factor is 2, is that the amount of growth, the numerical amount of growth, is double that which it was the previous input. Again, if we did 3, we would get 3 times 2 to the 3rd power, which would give us 24. And so now, for a 1 unit increase, I get a rise of 12, which is double this line here. Represents half of that increase right there. Let's look at an example. According to Kelley Blue Book, a car typically loses about 17.9% of its value each year. Suppose you purchase a used 2011 Honda Civic Hybrid sedan for $14,800 in 2013. About how much did the car originally go for back in 2010 when it came out? Okay, so we know, since there's a decay rate of 17.9%, that means if this is 17.9%, then what we have left of the value every year is 82.1%, which is the difference between 100% and what we remove. So our setup would be something like this. Y equals, if this were using x and y, our initial value times our decay factor, which would be 0.821, raised to the x power. Well, in this case, we're talking about the value and we're talking about time. So I'm going to use the value as my output, and the value depends on how many years have passed. Okay, so I want to determine what it was worth when it first came out. So what was the initial value? I know that 3 years after the fact, it was worth $14,800. So 14,800 is the value when 3 years had passed. So in other words, the thing I need to know is, what is my initial value? Well, all I really have to do is solve this equation here. And in order to do that, well, first thing I should probably do is maybe evaluate 0.821 raised to the 3rd power, which gives me 14,800 equals 0.553, and I'll just round it to 4 decimal places, 0.5534 times the initial value. Well, this is now a division problem, so I can solve for that initial value and find out that 14,800 divided by 0.5534 tells me that the car originally went for about $26,743 and $744